Welcome. In this particular video, we'll be analyzing quotients with scientific notation. Let's take a look at our example 1. Simplify the quotient 4.6 times 10 to the negative 2 divided by 7.2 times 10 to the 5th. Write the answer in scientific notation. Well, first thing first, let's recall what does it mean for a number to be written in scientific notation. Any number is written in scientific notation if it's in the form n times 10 to the a, where n is a number between 1 and 10, 10 being excluded, and a is an integer. Now what we're going to do here, we're going to take the quotient into two parts. First, we're going to be dividing this 2, and then we're going to use the properties of exponents to divide these two components. So first thing first, we're going to divide the 4.6 by the 7.2. We can actually use technology for that. So we can say, okay, 4.6 divided by 7.2, it's approximately 0.638 repeating. So we can say, well, this is going to be 0.638 repeating. Now here we have times 10. Since we're dividing the same base, we're going to keep the base and we're going to subtract the exponents. So we have negative 2 minus 5 based on the properties of exponents. So we end up with 0.638 bar, indicating that the 8 keeps repeating, times 10 to the negative 7. Now this number is still not in scientific notation. Why? Because this particular number is actually not between 1 and 10. So we're going to move the decimal point once, and notice you're going to end up with 6.38 bar times 10 to the negative 1 times 10 to the negative 7. One more time, using the properties of exponents, since we have expressions or factors that involve the same base, we're going to keep the base and we're going to, in this case, add the exponent. So we end up with 6.38 with the bar on the 8 times 10 to the negative 1 plus negative 7. So you get 6.38 times 10 to the negative 8 because we are adding two numbers with the same sign. So we add the absolute values and then we keep the negative sign in this case. So we can conclude therefore that 4.6 times 10 to the negative 2 divided by 7.2 times 10 to the 5th, it's equal to 6.38, where the 8 keeps repeating, times 10 to the negative 8. Let's see a couple more examples. Example 2. Simplify the quotient 9.28 times 10 to the negative 3 divided by 1.1 times 10 to the 5th. Write the answer in scientific notation. One more time, we're going to take this quotient into two parts. This one that involves the two numbers that are not having the base in common, and this two that have the base in common. So what we're going to do, we're going to use the technology for this particular components. So we have 9.28 divided by 1.1. And that gives you about 8.40363636. So we can see that the 36 keeps repeating. So we can say this is about 8.40 or 8.436, where the 36 keeps repeating. So going back to our notebook here, we can say, well, this particular component, it's about 8.436, where the 36 keeps repeating, and then times, since we're dividing the expressions with the same base, we're going to keep the base, and then we're going to subtract the exponents. So times 10 to the negative 3 minus 5. In this case, we end up with 8.436, where the 36 keeps repeating, times 10 to the negative 8. And now notice, in this case, we don't have to do anything else because this number is already between 1 and 10, and we already have this being multiplied by 10 to a specific integer. So this is already in scientific notation for us. So let's take a look at one last example. Example 3. Simplify the quotient 7 times 10 to the 5th divided by 8.2 times 10 to the 1st. Write the answer in scientific notation. One more time, what we're going to do, we're going to divide these two factors here, and then we're going to apply the properties of exponents to the factors involving the tens. So let's take a look at the calculator. We are going to divide 7 divided by 8.2. Now notice here that we have this particular digits. Okay, so we have 0.85, 36, 58, 54. So going back to our notebook, we can say that that part is about 0.85, 36, 58, 54 times 10. Now, we're going to keep the base, and since we're dividing, we're going to subtract the exponent. So 5 minus 1. So this is 0.8536585 times 10 to the 4th. However, this number is still not in scientific notation. Why? Because this number is not between 1 and 10. So what we're going to do, we're going to move the decimal point once here, and we're going to get 8.536585 times 10 to the negative 1, because we moved it once here, times 10 to the 4th. So rewriting this one, we get that this is 8.536585 this is a 4, times 10 to the negative 1 plus 4. Since we're multiplying two expressions with the same base, we keep the base and we add the exponents. Rewriting this one, we can say that this is 8.536585 times 10 to the negative 1 plus 4 gives you third power. Okay, so we can then say that this particular quotient, okay, we can say therefore 7 times 10 to the 5th divided by 8.2 times 10 to the 1st is equal to this particular expression. Okay, so in this particular video, we're analyzing quotients with scientific notation. Notice that we actually use technology to do this particular quotient, and then we use properties of exponents to simplify this one. And eventually we were able to go back to rewrite the numbers in scientific notation. So we're going to stop here. Thank you for watching, and have a wonderful day.